Artificial intelligence, machine learning, computer vision. These terms have increasingly become more commonplace in today's society. But what exactly do these terms mean? And how can we get started using them? Well, today I'm going to be talking about computer vision with Go, and I will explain how fun and easy it is to get started, and how you don't need to have a PhD in mathematics or a degree in data science to get started. So a little bit about me. I'm a senior software engineer at a startup in Los Angeles called Cargomatic. I'm a gopher, and I've been coding in Go for the last 4 years. I'm a painter, and I'm also a hiker. So a little bit about my talk, just to give you all an outline of what to expect for today. I'm going to be going over a brief overview of what computer vision is, as well as machine learning. And then I'll go over some of the paid and free tools that you can use, and then demo one of the tools, specifically GoCV, which is Ron Evans' Golang wrapper for OpenCV. And then I'll go into the future of artificial intelligence and our responsibility as developers developing apps in computer vision. So before I talk about computer vision, let's talk about how vision is important for human beings. There are so many tasks that we rely on our vision for. For example, driving a car or walking down the street. We wouldn't be able to read the signs that we pass by without our vision. So in the same sense, when scientists are building artificial intelligence, computers or machines will rely on their ability to see and understand the world around us in order to complete some of these tasks as well. So a little bit about the history on computer vision. It's actually been around with us a lot longer than we think. So development in computer vision started in the 1950s with rendering 2D objects. In the 1960s, we moved into 3D objects. By the 1970s, computer vision actually became commonplace. So in 1974, they came out with the invention of the bar scanner, which is available in any grocery store today that uses computer vision. By the 1980s, optical character recognition, or OCR, was birthed, and that gave computers the ability to read text. By the 1990s, we were able to gain speed and accuracy and more recognition of objects. And then by the early 2000s, we were able to have computer vision on our phones, where we were able to swipe and create gestures on our phone in order to communicate what we want to be done. So all of that uses computer vision in order to understand the patterns. So where we are today, well, besides further increases in speed, accuracy, and recognition, it's also even more commonplace today. So you can think of Snapchat, for example, where there are filters that are applied to the face, or in Facebook, there's now facial recognition, so that's really commonplace as well. As far as the speed goes, there's more and more algorithms that are coming out, such as RCNN and YOLO, which is short for You Only Look Once. But it's more and more commonplace, and more applications are being built using computer vision today. So how exactly does computer vision work? Before you start building your own computer vision apps, it's a really good idea to just understand the basics on what computer vision is and machine learning as well. So here's a picture of a smiley face emoji. When you blow it up, you can actually see that a smiley face, this emoji, is actually just an array of pixels. Each pixel is actually a numerical representation of a specific color. In this case, it's a color image, so there's an RGB value associated with it. RGB stands for red, green, and blue. If it was a black and white image, it might only have 2 values associated with it. But in this case, it's color, so there's RGB. So it's just good to know, just at a basic level, that an image is just an array of numerical data. So I like to think about some of the old arcade games from the 80s and 90s, Pac-Man, for example. So you can see very clearly that when you were playing the games back as a kid, that all the graphics we're pixelated. And that reminds you that that's exactly what an image is, an array of pixels or numerical data. Today, it's really easy to forget that because of high resolution images. So when you're looking at the high resolution images that you see today, it's just really easy to forget that. But always remember an image is just an array of pixels or numerical data. So the simplest problem that a computer vision scientist would need to solve would be tracking a color. So this is an example of one person trying to track a colored ball, orange, for example. And so back in the old days, in the 1950s, for example, they would just basically go line by line within the image and then check to see when a specific color matched. So, okay, this RGB value matches the color orange. And then it would say, okay, all of these orange pixels found together form the ball that we were looking to track. But what about today's examples? Today we have more complex problems to solve. In this image right here, it's a soccer game at night. And what if we want to track the soccer ball? Well, there are many different things that we need to consider. The soccer ball, for example, can vary in size depending on its location to the camera. Also, the soccer ball has multiple colors to it. It's not just one color, it's black and white. There's also shading depending on the nighttime. So if it's closer to a light source, then you have more light on it, but more gray shading if it's in a darker area. We use machine learning to solve this sort of problem by training a computer on recognizing soccer balls, for example, in multiple different environments. And through that training process, a computer can then recognize the different features in different environments to actually understand when a soccer ball appears in an image. So let's go back to this smiley face right here. What are the different things that we can say create this smiley face? Well, besides the round, face, the eyes, and the smile, there's different features. Those are three, the eyes, the smile, and the face, but each of those can be broken down. So think about the face in itself and the circle. Looking at that, there's two vertical lines, two horizontal lines, and then diagonal lines that completely form the circle. The eyes can also be further broken down into different features, as well as the eyes. So what we just described is the very basics of the Viola-Jones algorithm, which is actually one of the first algorithms that was used for face detection. So right here, I'm just showing 4 different types of features that the Viola-Jones algorithm can detect, but there are plenty more features that the algorithm can detect to find objects. So let's take a look at a more complex example. Say we don't want to find just a smiley face icon, but we want to actually detect a face. Well, the Viola-Jones algorithm will be used to detect facial features, such as the bridge of the nose. So again, these are just 2 features that are found in a human face that collectively, when found together, determine the existence of a face in an image or a video. So one feature, again, is the bridge of the nose, where it's light here, light on the bridge of the nose, and then dark along the sides. And then the eyes, where it's dark around the eyes, but then light around the nose and the cheekbones. Together with these, and also other features that are found in a human face, collectively, defined the existence of a human face. So Viola-Jones algorithm here has detected all of the faces in this image. It was created in 2001, and it was used for the first real-time face detection. But we've come a long way, and Viola-Jones is an earlier algorithm. It's only used to detect certain faces in specific formats. In the previous image, you can see that they're all frontal faces, but features need to be extracted and classified for faces in different angles. And so if you're using a classifier to detect the frontal face, it'll only detect frontal faces. It won't detect when the face is at an angle or tilted. So that's where CNNs come in, convolutional neural networks. And that is specifically what Tensorflow uses to generate their graph models. So this is a really great image for describing exactly what a convolutional neural network is. As you can see, the input is a 24 by 24 inch pixel image. Now this could vary, but this is just the example that they're using. And they take a subsample of that and then extract features from the subsamples and then get a smaller subsample from that and extract more features, creating feature maps that can then basically show what an object might have as far as features in varying different environments. So the term convolution is a very accurate term for the process for training a convolutional neural network. Another thing is that when I decided to take a look at the terms that are used to describe a convolutional neural network, everything was related to a brain. So if you look in the dictionary what convolution means, one of the first terms that comes up is a subcutaneous fold in the brain. Neural also describes the brain at the base of the spinal cord where the cerebellum exists, and that's responsible for motor control as well as for cognition. So this got me thinking, what part of the brain is responsible for vision? I bet you guys weren't thinking that you're going to get a biology lesson today, but that's what we're getting into just for a short bit, just to understand, how vision works. So the part that's responsible for our vision is the occipital lobe. And when I looked up exactly what the occipital lobe is, it's responsible for our vision, which we're on it. We're already starting to train models to recognize objects that we see on a daily basis. It's responsible for reading, which came out in the 1980s with optical character recognition. But then we have problems with our occipital lobe and with our vision. For example, depth perception. Sometimes people have trouble understanding or seeing the distance involved. Then there's color perception, where some people have color blindness and they can't see certain colors. This is not a problem for computers. Sometimes we have difficulty tracking moving objects. And also we have partial or total blindness. If you think about our eyesight, we can only see at a certain angle. We can't see behind us. But there are cameras out there that can capture at a 360-degree view. That's already exceeded our ability to see. There's no problems with color perception or tracking moving objects. In fact, computers can track a whole lot more than humans can. And I can greatly see computer vision exceeding our own in the future. Depth perception is interesting because from my research on computer vision, I saw that there hasn't been a lot of development on it yet, but it's the next big thing. But Microsoft is actually heavily investing in depth perception. Here I am with some of my coworkers playing around with one of Microsoft's products that came out a few years ago called the HoloLens. And if some of you are not familiar with the HoloLens, it's a mixed reality headset. And mixed reality isn't something that a lot of people have talked about, but it basically allows you to create virtual objects in real space. So for example, you can put the headset on and you see everything that you already see today, but you can actually create a virtual object that would interact with our environment. For example, you can create a virtual ball and put it on this podium. But if you move the podium, then it understands the physics of the world that we live in, and that ball will drop to the ground. So it's really cool. I think it's the wave of the future, and it's exciting that Microsoft is doing that, and I look forward to see what they come out with next. So now that we understand what computer vision is, let's talk about machine learning and how do computers learn? Well, specifically for object detection, there's image classification. So we would basically need to feed computers or machines thousands of images in order for them to extract the features to learn what object it is we'd like to detect. So currently this is a very manual process, but in the future I can see that this sort of manual process will go away as computers and machines will learn to detect unknown objects and interact with them in order to understand exactly what they are. But in this process of training, there's also validation. And with each training level and validation, we need to make sure that we're proper validating in order to say that the machine has been properly trained. I like this image the best as far as explaining what machine learning is. Currently, it's classification by a human through images that are fed into an algorithm where features are extracted. And that algorithm can be very different. As we discussed earlier, there's the Viola-Jones algorithm, but also CNN, which is through TensorFlow. And there's RCNN and YOLO, which are more faster algorithms for speed and accuracy as well. So what about machine learning with Go? Well, there are a lot of packages out there right now. There's TensorFlow as well, but if you go to their website, it will actually recommend training in Python first and then deploying in Go. So there's currently a gap with machine learning in Go, and that's where, if you like, if you're a machine learning enthusiast, you can actually go ahead and fill in this gap. But the way that I feel about it is, why reinvent the wheel? If there isn't going to be an increase in speed or in accuracy by developing these bindings with Go, then I don't see a problem with doing the training in Python and then doing the deployment in Go. However, I'm sure that there are some of you out there that might have a differing opinion, and I think that it's fine to be a part of working on these packages and being able to do machine learning in Go, because in general, working with Go is a lot easier than other languages, and in my opinion, Python included. So if you're going to do machine learning in any language, if it would be Go, then it'd be so much easier and probably more fun. Now, computer vision with Go, I feel like there's a great benefit to deploying models with Go. And for any reason with Go and doing development, it's for its speed and near real-time processing, which is really important for computer vision. It's also a really clean and easy language to learn. And there's already a Golang wrapper for OpenCV that's really easy to work with. And I'm going to be doing a few demos using it, and you'll see how fun and easy it is to work with. So I recommend working with GoCV. There's also computer vision APIs if you don't want to use the Golang wrapper. There's the big companies like Google, Amazon, Azure, and IBM. They've all written Golang wrappers for their product, so it's really easy to just import the package and start working with it. And even if you use any of these paid computer vision APIs, they're really inexpensive. So the first 5,000 API calls that you do are usually free, and then $1 for every 1,000 calls thereafter. That's $1 US dollars. And then GoCV, again, it's an open source option. You can use TensorFlow, either pre-trained models or train your own models in TensorFlow and deploy them in Go. Just pretty easy, and there's no cost associated with it other than the electricity to run your computer. So now I'm going to go over some demos. Oh, has anyone seen the show Silicon Valley? Yeah, okay, awesome. So there's this one episode that came out, and one of the developers basically built a classifier on their mobile device, and basically it's called hot dog or no hot dog. So the developer displays this or shows it to their coworkers, and he takes the phone and he points at a hot dog, and it shows that a hot dog has been detected. But then he takes the app and then shows it to other food. He goes to the pasta, and it says not hot dog. And then he goes over to the pizza, and it's not hot dog. So today we're going to be doing a little bit better than that, because I'm going to be using a TensorFlow model that's been pre-trained on the COCO dataset. COCO is just short for Common Objects in Context. It's used to detect over 200 common objects. Some of them are food objects. So I'm going to be showing exactly what that looks like. Before getting started with this, though, and with the code, I had to install Go, obviously. and GoCV, and then download one of the TensorFlow models that have been pre-trained on the COCO dataset. If you go to my GitHub page, you'll be able to access all of these links. And I just have a README to walk you through all of this. So the first one is the hot dog. So it properly detected that. And then in the show, they go over pizza, which they detected as not hot dog, but it's pizza here. But we can detect other food items like banana. We can get that. It flashes. There we go. This was wrong. Oh, not good. So computer vision is still in development. It's on the Apple. And it does not detect Fruit Loops, but it does detect that it's a bowl. So the next demo that I'm going to show is emotional analysis using Azure Vision. And I didn't show code for the first one because that has TensorFlow code mixed in with it, and I don't want people to get too confused with all the TensorFlow code. The code that I wrote for the emotional analysis demo is a lot shorter and easier to read. So I hope everyone can see my code clearly. Can I increase the size? Okay, so here I'm importing a package that is basically a wrapper uh, for the RESTful client for Azure Vision. And then I'm also importing GoCV. The main function is really short, as you can see, even blown up. It's about 10 lines, and most of it is just taking in a flag for the video, as well as the Azure Vision key and the host, and then creating the client. And then here we are just calling the display video function. So with GoCV, they have a video capture file method, but they also have one for capturing a webcam as well as for images. But in this particular case, we're capturing a video file and streaming that in. Then we create a window with GoCV to display the image, and then also a new mat, which is short for image matrix, which again is just a numerical representation for the image. Through this for loop, we stream through frame by frame, reading in the stream and populating the matrix with a pointer here, a pointer to the mat file. And we take that image and then using GoCV, encode that image into a stream of bytes encoded in the JPEG format, which is a format that Azure Vision accepts within the body of a post that you're sending it for facial analysis. In response from Azure Vision, we get all of the emotions detected in that person's face, but I created a method that just returns the dominant emotion. That dominant emotion is then put as text into the image, and then we show that image, and then wait, and then do again for the next frame. So rather than running this over our Wi-Fi, I decided to do a pre-recorded demo. And there's this one behavioral scientist called Vanessa Van Edwards, and she does a lot of videos online. So in one of her videos, she goes over different facial expressions that a person can make and then what they look like. Then at the very end of her video, she says, okay, well, guess like what emotions I'm showing on my face and see if you can detect them. But rather than me or you detecting the emotions on her face, I decided to send this off to Azure Vision and see how artificial intelligence does. So as you can see, it detects sadness, disgust, goes through all different emotions. And between each, there's a neutral face. So if you see neutral pop up, that's because she does a neutral face between each. And there's a slight delay. But again, there's two facial expressions that she does in the end. Both are labeled as surprise. But what's interesting with computer vision, it labeled them both as surprise, but this is actually fear, and that's surprise. So again, computer vision still has a ways to go. It's very good at detecting emotion, but not the slight nuances. For example, the difference between fear and surprise. So that's an area of improvement. Now, science fiction is really interesting because it gives us some insight into the future and what can be done with computer vision. So has anyone seen the show Black Mirror? It's a really interesting show, and it goes into a bit of techno-paranoia and into the future and what we can do with some of the computer vision tools or just technology tools that we're developing. There's this one episode that came out last year called ARKANGEL, and it's about an overprotective mother who decides to invest in this cutting edge device that basically protects her daughter from seeing anything that she doesn't want her daughter to see. For example, she doesn't want her daughter to see nudity or gore or violence or drugs. So all of these things can actually be detected with PicPurify, which is a vision API, a specific niche vision API. And I've integrated this in with GoCV just as a demo to see what a parent could possibly do or a technologist could build. So again, I'm not running this over the Wi-Fi. I recorded this demo, but the code is all available if you guys want to play with it. I also am not detecting nudity or violence. I decided to try and detect drugs and see what that would look like. So as you can see with this, the very first frames, PicPurify did not recognize the marijuana in smaller contents, but when grouped together, collectively, it blurred out the images because it did detect it. Also, PicPurify did not detect other formats of the drug. So I feel that that's just due to training. So if you train it to recognize as a specific drug in a specific format, it'll be recognized, but not in other formats if it's not been trained to recognize it. So how far away are we from actually creating an ARKANGEL product? Well, I did a little bit of research and I found that there's this one company out there called Eye, which is short for Enhance Your Eye. They're not the only company that's working on bionic eyes. There's also Second Sight. But they claim that by 2027, they'll be able to come out with 3 different eyes. One is the healing eye. So for anyone with a degenerative eye disease or with blindness, they'll be able to replace their eyes and be able to see the world around them. There's also Enhance Your Eye, which allows people to see better than 20/20 vision, and also filtering of the visual input, which sounds familiar. Filtering of the visual input is exactly what they're showing with ARKANGEL. And then the third eye, which would give someone the ability to actually stream their eyesight into the cloud using Wi-Fi. So also by 2027, or beyond our eyesight in 2029, they're projecting that artificial intelligence will actually exceed our own intelligence. So this is really good to remember, and it's good to know all of the possibilities out there and to realize that we have a lot of responsibility when we're building these computer vision apps. Everything that we build could potentially affect society for good or for bad. So always keep that in mind and hopefully create things for the good of society. So all of my code is available on my GitHub. The COCO demo, the emotional analysis, ARKANGEL, everything's there. So if anyone wants to download the code and play around with it, I'll be here walking around. If you have any questions or have trouble setting it up, I'll be happy to help you. And when I'm not here in Brazil, feel free to contact me on Twitter or via email. I'll be happy to answer. So, obrigado and thank you.
We have 10 minutes to questions.
Okay, good.
Pessoal, a gente tem tempinho para perguntas. Aí, quem gostaria de perguntar alguma coisa, o Vitor pode passar o microfone. Okay, just to break the ice, I have a question. Could you show us at least a little bit about the Go CV, at least the GitHub?
Oh, yeah, I will.
I didn't know about it.
So if anyone goes to gocv.io, this was developed by Ron Evans. His name is Dead Program on GitHub, and he has a really clear tutorial on how to get set up. Beyond that, he also has code on there on how to deploy TensorFlow models, as well as HAR cascade files, which utilize the Viola-Jones algorithm. So he's got maybe 20 or so different examples on how to build computer vision apps as well.
Other interesting thing was that quickly you open up your camera. Does that Golang code that opened the camera?
Yeah, it was. So actually, the ARKANGEL demo and the expression demo also they both import the GoCV package. And besides this, it's really in the display video function that you're calling a video capture file. What it really is that GoCV is a Golang wrapper for OpenCV. So most of the code, if you actually look at it, is all CGO.
Okay, got it. Okay. Mais alguma pergunta, pessoal? É isso? Então tá bom. So, thank you very much. Thank you, Marian.